Good morning, all of you.
Good morning, sir.
Good morning, sir.
So I think we have discussed last time about how to delete the last element of a linked list. That means the last node, not an element, because a node contains both element and the address of the next node, right? So we have discussed about deleting the last node of a particular linked list. So you already know how to delete the last node, right? Before you go to the last node and you are at last but one node, you have to identify that next node is the last node. Then you just cut off the link. So I'll just show you on screen so that you will again remember it. Okay. So, okay. So this is a node and this is another node. This is another node and this is another node. So naturally the last node will have none there. So your root is here and the traverser is also here. If this is the case, we will go from one node to the other starting from the root. Okay. So let us think our traverser is like a hero. Now we just write a small thing. The traverser is at last but one position and it wants to link it away. So that means you want to delink it. So the last bogey or the last node of a linked list should be delinked. So what you need to do is just make your address as none. If you find your next node's address as none, that means you estimate that it is the last node. And so simply make the traverser's next address as none. So it will be delinked. This is a simple technique that we have used. And last time we have also discussed that you cannot directly delete a node. Deleting in a node means you are just cutting down the link. This is what deletion. So if you want to delete a node, you need to delete the link that is connected to the linked list. Okay. So regarding the deletion of nodes with a particular value, let me draw a complete diagram so that again we will discuss and step by step we will solve it, whether you have done it or not. So this is another node. Based on our example, I am going through 20. This is another node, 16. This is another node, 100. And this is another node, 120. Okay. Now let us write the addresses for this. The address of this is some random address 3121 6125 1012 2021 3456. Some random addresses. Because it is connected to this, naturally your other address will be 6125 because it's the next address, 1012 2021 3456, and the last one is none. Okay, so this is what we had our linked list, and I want to link it with the root. So my root is this one, and my traverser is also pointing to this. So now let us discuss this thing. I want to delete a node with 16. So let me write with something like I want to delete a node with value 16. So what you need to do? You need to identify where the 16 is. Okay, let me discuss with you a small thing. So in this case, if you are moving traversal from one node to the other node, anybody has any idea of how you can delete a node with value 16 so that your linked list should be the continuation of 5, 20, 100 and 120 and 16 doesn't appear in this. Any idea from your side?
Sir, if the second node contains the address of the fourth node, like 2021,
Hmm.
then the middle one will be eliminated.
Yes, but how do you know that I need to delete this one and write 2021 here?
If root dot data equal to 16, then replace the next address to the previous one.
Okay, you are directly moving the root or traversal?
Traverse.
Traversal. Okay, so according to you, you said that I need to go to the this one and see whether the traverser's value is 16, and if it is 16, you need to delete the data. Yes, right? So if
Delete
it
the
is
data
so,
and the next address should be given to the previous ones.
and now is it right? Like whatever I have written, right? Your idea, like the traverser comes to the node which
Yes.
has to be deleted, and yes, right?
Yes.
Hmm. Okay, I will just draw a small diagram. I think you all know that in Telugu also we have a small thing, right? Uh, mm, మనకి అంటూ ఉంటాము కూర్చున్న బ్రాంచ్ని నరుక్కోకూడదు సంథింగ్ సో I had a very small story where a person who is a tree cutter actually sitting on a branch and he's trying to just cut off the branch for his own purposes. But the problem is this fellow is sitting on the branch in which he is cutting down. But there is another person who is very good at that, and he is doing something like he is sitting on a branch the same way, but he is trying to cut down not his branch which is connected to the tree, but this one. See the difference. So a person sitting on the branch which he wants to cut down, and a person sitting on another branch and cutting down the remaining branch of it. So that means you need to understand here which one is correct. This one is correct, right? This one is wrong. You are also falling down, but you should not fall down. You should be sitting in another branch or distance of it where you are cutting down and cut down here. So you will be safe. The same thing happens here in the linked list also. When you are at 16, how do you delete it? Deleting is just deleting the link in the linked list, not deleting the node. So if the traverser is at the node 16, you can never delete traverser. So you lost your point of deletion. So విలువైన time ను పోగొట్టుకున్నాం మనం. So before you come to the 16 node, you have to identify where the 16 node is and cut the link, and as somebody said that we need to connect the address to here. So my idea is, based on the story I have told you, my traverser has to sit here and it needs to identify if its next address value is 16. What is its next address? 1012. Okay, this is the 1012 node. What is its value? 16. We can find out like that, right? So I will tell you what are the things that are really necessary here. The statements that are necessary are traverser dot value, okay, traverser dot next address, traverser dot next address dot next address. The last one will be traverser dot next address dot value. Now, can anybody decode what are the things that will be there? So what is traverser here for the first point? Can anybody tell me? What is
20,
traverser?
sir.
No, it's not 20. Traverser holds the address actually. Traverser dot value is 20.
6125.
Yeah, it is 6125 dot value. So 6125's value is nothing but 20. Maybe Saurit, if you said that traverser dot value is 20, that's correct. But I thought that you are telling about traverser. Now next decode this one. What is TRA?
1012, sir.
Yeah. No. What is
1012.
TRA? TRA.
6125
Travel-
dot next address.
6125.
6125 dot next address. We will decode slow one by one, not the answer. So 6125 next address is nothing but
1012.
1021.
1012. Next, decode this one. 6125
6125.
dot next address, right? What is 6125's next address?
1012.
Yes, 1012 dot next address. What is 1012's next address?
202.
Yeah, 2021. So finally, you even got the alternate one also. Okay, using the traverser here at this position, you even got your alternate address also. Okay, now decode this one. What is TRA?
6125.
6125.
6125 dot next address dot value. What is 6125's next address?
1012.
1012 dot value. What is 1012 dot value?
16.
16. So I think you got few answers from here, these statements. Using these statements, now we need to form an idea about how to assemble them so that the link of 16 node will be disconnected and it will be connected to the 100. Can anybody tell me an idea about that? How do you do that? So here the first step that you need to follow is identify whether the next node value is 16 or not. That means become the given value to be deleted. And next, disconnect it and connect to the alternate node. So these are the two steps that you need to follow. So now can you tell me in a code basis, what are the things that you need? Forget about loops. For example, we are there in this position. So what are the statements that really help us to do this?
So we can put a conditional statement that if traverser dot next add dot value is equal to 16.
Okay. So tell me if traverser
dot next address
dot value
is double equal to 16.
16. So traverser dot next address dot value is equal to 16. If it is so what should you do? Because you identified now. The first step is over with the function. Now next, disconnect it and connect it to the alternate node.
Traverser dot next address equals to traverser dot next address dot next address.
Yes, traverser dot next address is equal to traverser dot next address dot next address. So I will decode this one. What is this statement? Okay, I will rub these things and decode this one. Whatever statement you told. Okay. So whatever told by Saurit is, now our traverser is here, right? So he says that if the traverser's next address dot value is equal to 16, naturally the traverser's next address is this, and so this is the one next address and its value is 16. So we identified that next node is 16. So what he says that traverser's next address is equal to, I'll rub this one also. Traverser's next address is equal to traverser dot next address dot next address. Okay, so this is the one. So let us decode this. So what we are giving to the traverser's next address? The current traverser is 6125 naturally. So next address dot next address. 6125's next address is 1012 dot next address is nothing but 2021. So you are giving this 20212 to traverser's next address. So what will happen now? You are rubbing this the previous value and replacing it with the new one 2021. So naturally what is happening here, because nobody is holding the address, this is actually delinked or disconnected. This is directly connected to this one. You see here, this one is directly connected to this one. So if somebody asks you to read, it will read like this. It will print 5, 20, 100, 120. The reason is 5, after 5 it will come to 20. After 20 it will directly go to 100 because it is now connected, right? 16 is disconnected from the linked list. And then it comes to 120. So simple, right? So our task is keeping this in mind, keeping this condition in mind, we need to write a while loop now because your traverser has to jump from one place to the another place to identify what are the things that are really necessary here. Where to actually stop and disconnect the next node and connect to its alternate node. So up to that we need to traverse, right? To traverse from one node to another until this condition satisfies, we need to use a while loop. Let us now use a while loop. I think this is the one which I have. Yeah. So I have written a function for you or delete. So we need to fill up this function. So I will put more values into this. Insert root dot 120. Okay. So let us go through this one. So I want to delete 16. Okay, it's the same example. Okay, I will start from the first. So, okay, now coming to insert. So after insertion, let us see what will happen. So new nodes are created. You know how to insert every node, right? So simply I am bypassing it because I am creating the nodes. You know the traverser traversed to the holes, node by node. The whole statement will be covered to traverse, node by node. Now it is calling to the 52nd line delete value based. So we are sending the value and along with that the traverser. Now let us write the function now. So as I said, there is no need of any new node or something because we are traversing like the display only we write. But the only thing is we just copy this one and we can paste it here. So the same statements but small change. Let me write it so that you will understand. While the condition that we have discussed yesterday, in the previous board, traverser dot next address dot value. I think it's the value that we have written here, right? Yeah. Traverser dot next address dot value. I consider value because the value is part of your object. Next address and value are part of your object because you created the node with those two items. So I am saying that is not equal to 16. So until it is equal to 16, your while loop repeats. So while it is not equal to 16, you need to go into the loop and traverse the whole thing. So you will say traverser is equal to traverser dot next add. So until it is 16, you will go through like this. Okay. So when the next node's value is 16, when the traverser's next node value is 16, the same as next address value, right? Next address is nothing but next node. So the traverser's next address value is 16. Then come out of the loop, break the loop, and then what you need to do, the same statement that we have discussed earlier. Traverser traverser dot next address is equal to, and I'm typing here, please follow it because it's a live programming, it's going like that. We are at the 32 line. I don't know why it is disturbing more for your class. It doesn't like, I think. Yesterday it went on properly, like our none, what we have discussed on Monday. It worked yesterday again in CS class. I don't know. So the traverser's next address is equal to traverser dot. See, I'm typing here the red line that is marked. Next address dot next address. So what we are doing, the traverser's next address is given to the present traverser's next address. So we are simply asking like what is the current traverser's next address and what is its next address. Now you replace the current traverser's next address with the new address that is obtained. That's what this statement means. Okay. So now let us continue with our thing. We are at this position, right? Delete. Okay. Okay, it's already deleting it. So I will come back again. Okay, now we are at 56th line. You can see carefully. Delete value based node 16. So we are at the 27th line. See what will happen. So while traverser next address value is not equal to 16, at present the traverser is here. You can see the red mark. Okay, the traverser is holding the node which is having a value 5. What is its next address value? It is 20. See the red point. The next address value is 20. So naturally it will go inside because it is not 16. It goes to 30th line and it says the traverser is equal to traverser next address. So now this red point will point to this, you see. Okay, now you see. It came to the node which is having the value 20. Next. So this time the traverser's next address value is 16. See, this is the traverser which is holding the value 20 and its next address is nothing but the next node. Value is 16. So it comes out of the while loop. It came to 32nd line, you can see. Now it says the traverser's next address is equal to traverser's next address, next address. Now let us decode this one. So the traverser is this one, which is holding the value 20. Its next address is the node which is holding the value 100. So what we are doing now, the address of the node which is having the value 100 should be now connected to 20. So see how it will be connected. Yeah, I think you understand this, right? The traverser is holding a node with value 20 and the 16 has been eliminated from the list. And now it is connected to the value node 100. So the statement means that. The 30-second statement means that. So it's all like you, if you understand what is the address, what is the next address, imagine you work out on a paper on how I am working it down. So I have slowly done it right. So you also do the same thing so that you will inculcate the idea about how to do that. Okay. Now I will give you 10 minutes of time. You just practice yourself now. Open Python tutor and practice yourself. Deleting this node. Sushant, you have sent a statement. This one, I think by now you might have understood what's wrong with the statement that you have sent. So when the traverser is at the root node, because its next value is not 16, it will come out of the loop. So what is the use that if it come out of the loop, it will never traverse and never find 16, Sushant. Okay. So your statement goes wrong. It's not double equal to, you have to go for not equal to. So whatever you said is correct, but that is for the if condition. So if the condition 16 is satisfied, then you are doing correctly. But it's not for the while loop. It is for the if condition. Why we are using while loop? The while loop is used here to make the traverser traverse from one node to the other node. So if the condition, so if it stops at some node, that means it is not satisfying the condition. Then we have to do like traverser dot next node is equal to traverser next node dot next node. It is not slightly reverse in while loop. In if condition, we write the condition that we have done here. But in while loop, we do it in a reverse condition because we want to move from one node to other node until unless we find that the other node is 16. Sushant, I think you understand that. Okay. So if you have done it, let's come to a new concept. So until now we have been discussing about how to insert in a single linked list. Why I'm calling single linked list? Because every node has only one next address. That too, it is only in the forward direction. So you can observe this here. You can only go in a forward direction, right? Only in a forward direction. So I will just a small thing. So this is the only thing that you can go through. This is the forward direction that you have, right? If you are at node 100 and if you want to come back, you cannot come back. You cannot come back to 16, you cannot come back to 20. You end at 100, that's all. It's quite bad. Why can't we move here and there whenever we want that? Why can't we move forward? Why can't we move backward? So that means single linked list which is having a single next address pointing only to its next address can only make a traverser traverse from the first root node to the end node in a forward direction, only in a single forward direction. If I want to come back to read it, it is not possible for me in this case. So until now we have only done insertions, deletions, displaying everything. We can also search, not a big problem. Search is also very easy. You can do that. Because you traverse from one node to other node, wherever the traverser's value is that value, you will say, yeah, I found out that this node is present. Okay, that's not a big problem. But how can you think about that you have to come out, come back? Any idea from your side? How do you put so that you can come back to the node and you can read it? At any point of time, if I want to. Any idea?
So maybe we can add a third attribute to the class, which is like, for example, previous address,
Okay, that's
and
correct.
that is storing the address of the previous node.
Like double linked list, sir.
Yes, correct. So that is one option that we have. Good. We have double linked list. Any other thing that you can have along with this? Okay, I will tell you. The other one is circular linked list. This is also possible for you to have it. So let me discuss about circular first. Then we will go to double linked list. Instead of keeping it none here, why can't we write the address of the root node? Why can't we get the address of the root node every time? Every time whenever we want to read the address of the root node, we will write the address of the root node here. So 500 again, 520 1600, after 100 the next address is 5 again, right? So 520 1600 again, after 100 the next address is 5. Okay, we can repeat any number of times. If you want to go back, you can do it. You can do it to go to the past. Of course, the advantage of double linked list is different and the advantage of circular linked list is different. Don't compare between them. But those two have something common, right? After we reach to the end node, we can also go back to read all the nodes again. So this is possible. For both of them, this is the commonality that we have in this. Okay. Now, how do you apply this one? If you want to form a circular linked list, how do you apply this? What is the change I have done here? What change I have done here?
In place of none, we are placing the first roots.
Yes, correct.
First root
That
address.
means I will give you a small hint. If you want to try, you can try out the program. If I first create a root node, I will give the conditions also to you. I will first keep none here. If it is root node, I will keep none. Okay. Whenever you are creating a new node, so every time when we are inserting something, we are creating a new node, right? New node. Okay. The traverser also will be here anyway. So you will have the next item as 20. So this time, every time last we have discussed is when we are inserting a new node, you can just observe. So this is the new node which I am highlighting now. Every time we are starting with none, right? We are starting with a none. When new node is being created, we are saying the value and none. So instead of none now, what I will do, I will keep the root itself. For example, the root's address is 2125. So I will simply write something like this. I'll write root here instead of none. So root is nothing but 2125. You will have 2125. That means a new node without even being connected to the linked list actually points out to the root already. So it's forming. And because the traverser cannot move forward, only one node is there until now in the linked list, and its next address is none. What you can simply do is, instead of none, you can write a condition. If its next address is none, there is no need for you to traverse. If the current root nodes or traverser pointing to node is none, there is no need for you to traverse. This is one condition I am giving. So there is no need of while loop. Write an if condition, that's all. And keep here new node. It's nothing but its address. So maybe the address is 6150. So you will write 6150. So that's how the new node is given. So it will now get connected. So this is how I am connecting it, right? So I hope you understand now. Again, I will tell you something. If I am now creating another new node, so already we formed a circular linked list with two nodes and the last node connecting to the root node. Again, we are forming a new node. So this is not the new node now. This is the new node which we are creating now. This time you have 16, and instead of none, you simply do like this. You put root instead of this. So you will have 2125 here, and it also gets connected to this one. It's still not added in the linked list, but it is already connecting to the root. Now what you do, because the traverser's next address is not none, you enter into the while loop. So you will say, put down the traverser again to the next. So traverser is equal to traverser next address. And the while loop should have a condition which should know that if the traverser's next address is root, so you are thinking that it is the last node. So what you will do immediately, you will say the traverser's next address is equal to the new node. So you will connect like this. You just think of, you will definitely get it. So you will say, I will write new node here. So the new node's address is 1012. So you will write 1012. So now it is connecting to this. And it is rubbed. Because this is changed, right? Now instead of connecting to the root, it is now connecting to the next node. See, again a circular linked list is formed anyway. So 52016 again, 52016 again, 52016. Now your task is to think of for some time and do it. Then I will help you. So I have given you a hint, right? You know how to insert a node. I have already given the hints. The root node should start with none. If the traverser is pointing to a node which is having none, simply you connect the new node to that. Don't go to the while loop. If it is not satisfying, then enter into else while loop, which you will test if the traverser's next node is not equal to the root. Then traverser is equal to traverser next node. You will repeat the loop until the traverser's next node is root. Then if break the loop, if the condition is not satisfied, come out and say the traverser next node is equal to new node. Same thing. So I will show the code for you how you are inserting. So do all the necessary changes what you want to do among these statements. While inserting in a circular linked list. Small changes are enough. So if anybody got an idea, you can also tell me how to do that. What changes I have to do now here instead of this? Can anybody tell me?
The roots.
Yes, root. Okay, instead of none, we are keeping root. And because the traverser is pointing to the root now, what condition should I need to write before I go to the while loop? So when you have only one node, that is the root node in the linked list, do you need any while loop? You can directly write, right? So tell me the condition, what condition I need to write? If, what is the condition?
Traverser now dot next address equal to root.
Traverser dot, and not next address is equal to root, but traverser is itself root, right? So traverser dot next address is equal to none, because the first node is having none. You see here, the root is created with none, not the root itself. How can it point to itself? So you have to change some changes here. If you, it has to point to itself, you need to change something like instead of none, you need to keep self. So anyway, we are going only with the none. So the first node is having none, as I said in the diagram. You can see here in the memory also. So whenever the traverser is pointing to a node whose address is, next address is none, don't go to the while loop and keep it like this. Simple thing. So you will say traverser next address is equal to new node. Simple. If the traverser pointing to the address is not none, then you will say else, and now you will go to the while loop. I hope you are understanding this. So, yes, have you understood?
Yes, sir.
So traverser initially points to the root, and if it is the only node that we have in the linked list, and because it is having none in the next address, create a new node going to the root, and your traverser's next address is anywhere none, so naturally your traverser next address is equal to new node. So at this moment, at the 41 line, we are forming another node in the linked list. Now we have two nodes in the linked list. That's fine. The first root node is connecting to the next node, and the next node is the last node. Right. Again, after that, we are connecting to other one, 16. It's the third node. Again, the traverser comes here. New node is formed with the root connection. Now you will check. Anyway, traverser next address is not equal to none. So always it comes to else. So you will say, if traverser's next address, now you need to change something here. Where do you stop looping it? So that you will stop and connect it to the last node. How do you know something is the last node?
Until the next address is root.
Yeah, correct. So instead of none, it should be root. So here a slight another thing is that instead of none, we are not having anywhere none, right? Everywhere you are having root only because you are creating new node with root. So always the last node will have root only, not none. So wherever you find root, then see, until you find root, you go traverser is equal to traverser next node. If you find root, break the loop, come here and say traverser now dot next address is equal to new node. Okay. So we have changed the simple thing. Let us see what will happen now. Okay. So our root is already created. So we are in the 52nd line where we are inserting the root. Sorry, inserting 20th node. You see how we can insert. Okay. So in the insert function, the traverser is also pointing to the root node.
Sir,
And we
in
are
depth
creating.
we haven't inserted root, sir. We
Amma?
tell that it traverse, sir.
అర్థం కాల.
In new node, sir, in new node value comma root, sir. Their root is not defined, no, sir. There it will be traverse once.
No, it can. Correct. So, yes. So, yes. Now we will do it. That's correct. See, what will happen? Let us find the mistake here. So, 38. Now, it gives me that name root is not defined. Okay, now if possible, I will put traverser here. Okay, as you said, I will keep traverser everywhere where it is. Where I am. Where I am now? Traverser. So here also instead of root, I will keep traverser. Okay. Now let us see what will happen. Okay. Now it is saying that running 100 steps. Now you tell me what is the wrong in this. Now we will come back, right? We will come back and again look into that. So traverser is pointing to the node. We have new node. So not a problem.
Sir, or
So
else can we make another parameter? Insert.
we need to make another parameter. First, we will run this and people will understand what is the mistake. Then we can do for another parameter. Okay, now because we are moving the traverser, we never can compare traverser and we did not have root. So let us see what will happen. So what we say, if traverser dot next address is equal to none, until then fine, not a problem. It will be done. So you can see that simply that 20 is connecting to 5 and 5 is connecting to 20. Now a circular linked list is formed, right? Until here. Now coming back, now we are putting 16 here. You see carefully. The new node is being created.
11 o'clock.
Just 2 minutes. I will get down. So now you see the 16 without connecting to the new node is still connecting to the root. So it is trying to form a circular linked list. Now our task is to do it now. It is not none. So while traverser, so you can see that the traverser is going from one to the other. You can see that it is going to the infinite loop. How do you identify where to stop and insert the new node into that? As your friend suggested, let us receive something like root duplicate. We use root duplicate as a standard point and we use traverser is equal to root duplicate. So everywhere I use only root duplicate and move the traverser from one node to the other node. So root duplicate will always be standard, connecting to the root only. Okay, and the traverser only will move so that I am not losing the connection. So I will have root duplicate. I hope you are understanding, right? I am receiving the
Yes.
root's address into the root duplicate and I am again duplicating it. So in this, root duplicate will remain standard with the root address and traverser only moves from one node to the other node. So in this case, everything will be fine. Now we will see the next one, what will happen. Yeah, you can see That 5 is connected to 20 and 20 is connected to 16 and 16 is again connected to 5. Little bit confusing with arrows, but you can still see. The 5 is connected to 20, right? 20 is connected to 16, 16 is connected to 5. It is forming a circular linked list. So root is 5, 5 to 20, 20 to 16, 16 to 5, right? So if you add another node also, it will do the same thing. So you are already forming a circular linked list every time. So you just try out this one. You take a screenshot, and before you come to the 12 o'clock class, if you have time, you can try out. Okay then, bye bye for now.